Okay.
Hello. Today we're going to be working on chapter 16, problem number 12. Okay, so the problem states the mass of a string is 5 times 10 to the negative 3 kilograms, and it is stretched so that the tension in it is 180 newtons. A transverse wave traveling on a string has a frequency of 260 hertz and a wavelength of 0.60 meters. What is the length of the string? So, the first thing we're going to do is draw a diagram, which I've already drawn so that we can better understand the question and find ways to attack the problem. Okay, so basically we have a string. Here's my string. And what we're given is that the mass is 5 times 10 to the negative 3 kilograms. We have a tension of 180 newtons. And we have a final, and what we want to do is find the final length of the string. And so another thing that they gave us is that we know that we have transverse waves, and it has a wavelength of 0.60 meters, and it also has a frequency of 260 hertz. So this problem is loaded with tons of information that we can use in order to figure out the length of the string, which is what we're trying to find. Okay, so how will we go about attacking this problem? Alright, the first thing we're going to do is we're going to use the equation in the book that was given to us. So the equation that's in the book that was given to us in chapter 16, I believe is equation 16.5. Okay, the equation is the velocity equals the square root of the force divided by the mass times the length. So this is the problem that we're given, and what we're trying to do is find the length. So in order to find the length, we need to first we want to get the length by itself. So in order to do that, we're gonna have to square everything and then just manipulate it in order to get length by itself. But before we even do that, we see that we're given velocity. And our price of the equation, it's not giving us velocity. It's giving us frequency and wavelength. So what we want to do is use the equation velocity equals frequency times wavelength in order to solve the problem. So we're just basically going to substitute velocity for frequency times wavelength. So that's going to give us frequency times wavelength equals the square root of F, which is force, times force divided by the mass times length. So force M divided by L. So this is what we're going to be using to get the L by itself. So what we're going to do now is get L by itself. We're going to do that by squaring both sides. Okay, so now after we squared both sides, what we're going to do, we're going to have... And we're going to square both sides times the M times the L divided by the 5 wavelength M in order to get length by itself. So the final equation is going to be So that's what we have right now. So now we're going to just basically plug and chug all the information we were given. We were given the frequency, we were given the wavelength, we were given the mass, we were given the force. So what we're going to have now is 260 hertz squared times 0.60 meters squared times 5 times 10 to the negative 3 kilograms divided by the force, which was 180 newtons. So this is what we have next. As you can see, this problem. So when you solve everything, you're going to get L. And in this case, by plugging everything into a calculator, you find out that L is equal to 0.68 meters. So this is the final answer, 0.68 meters, of what the length of the string is. Thank you, and have a great day.